Good morning, students. Let us get into our third unit, which is synchronous sequential circuit. Okay, synchronous sequential circuit. Okay, so before going into the design aspects of synchronous sequential circuits, we'll have to know something very basic about these particular circuits, which will help us to design more complicated problems as well as the easier problems. Okay, so we have already studied what is a combinational circuit in our previous chapter. So let me quickly brush up. Okay, so what is a combinational circuit? So combinational circuit is a circuit, the output variables at all times are dependent on the combination of the input variables, right? So it is dependent on the combination of the input variables, right? We know this very well, right? Combination of input variables, correct? So we know this, already we have studied this. So what exactly is the difference between a combinational circuit and a sequential circuit, right? So the one major difference between the two is, let me explain you all with the diagram over here, a simple block diagram. So we have a combinational circuit here. This is a combinational circuit, okay? And we have our inputs, okay? So you will get your outputs over here, and if I include the memory elements, okay, this exactly is what? This exactly is nothing but a sequential component, okay? This exactly is a sequential component, and this has something called as the present state and the next state, okay? That is, more precisely, the sequential circuit as a memory unit is required to store the past history of the input variables in the sequential circuit. Understood? So this is what is the main difference between the combinational circuit and a sequential circuit. Okay, so knowing the difference between the two, okay, I want to specify one more thing. So when it comes to a combinational circuit, memory unit is not required. We have already studied this, right? Memory unit is not required in case of the combinational circuit, but in case of the sequential circuit, we require the memory element, which is a crucial part of a sequential circuit. That is the major difference. Another major difference is a combinational circuit is very easy to design when compared to the sequential circuit. Sequential circuit is not that easy as our combinational circuit to design. Okay, so if I have to give an example for the combinational circuit, I can give an example of parallel adder. Okay, so parallel adder is a very well example for the combinational circuit, and for the sequential circuit, I can give an example of the serial adder. Okay, so I guess now you are very well understood the difference between the combinational and the sequential circuit. Correct? Now, before going into the design aspects of the sequential circuit, we'll have to know some basic concepts. Okay, let me rub this for you all. Okay, so before going in depth in the sequential circuits, we'll have to know something on synchronous sequential circuits. Okay, the synchronous sequential circuits can affect the memory elements only at the discrete instant of time. Okay, it can affect the memory elements at discrete times. Okay, at discrete interval of times. Okay, now when I say synchronous sequential circuit, there are two types. Okay, let me quickly brush up through the two types. That is synchronous, and another one is asynchronous. Okay, the major difference between the two is, in case of synchronous, memory elements are clocked flip-flops. Okay, are clocked flip-flops, and Here the memory elements are either unclocked flip-flops, or time delay elements. Okay, so this is the major difference between the two types of synchronous sequential circuit, that is synchronous and asynchronous. Okay, and next simple difference I could tell you all is it is easier to design. It's easier to design, and here it's more difficult to design. Okay, so more difficult to design. Dear students, when you concentrate your third unit, you have everything related to your synchronous sequential circuit, that is the design aspects based on the synchronous sequential circuit. Your fourth unit will be something which will concentrate on your asynchronous sequential circuit. Okay. Now, if I have to, take you all to the design procedures, you will have to know certain basic things, which I will tell you all. Okay. So, before going to the design aspects, you have to know something which is very crucial. Okay. So, that is, you should know something called as present state. Okay. So present state is nothing but, the status. Okay, when you say the state, it means the status of all the state variables. Okay, the status of all the state variables at time t. Okay, before the next clock edge represents the condition called as present state. That is, it indicates the status of all the state variables at time t. Okay, so it basically tells us what is this present status of a variable. That is what is called as this present state. Okay, and what is the next state? What is the next state of a variable? Okay, the status of all the state variables at some time. Here it is time t. Here the time is going to be t plus 1. Okay, which represents the status of a particular state variable at the time t plus 1 is called as the next state. Okay, so these two are the important aspects to analyze any synchronous sequential circuit. You have to know what is the present status of a state variable at time t, as well as you have to know what is the next state, that is, what is the next condition after the present state when your time t is equal to t plus 1. Okay. So the synchronous sequential circuit I can categorize into two main types. The first type is called as the Moore model, and the second type is called as the Mealy model. Okay. So these MEALY, Mealy model, these are the two models which are the most important models which comes under your sequential circuits. Okay. So the major difference, or I can say, the crucial difference between the two models are something like this. Here, the output of the Moore model, that is, the output depends only on the present state of the flip-flop. It depends only on the present state of the flip-flop. Okay. I shall show this with a state diagram, okay, so that you can understand it much better. When I come to the Mealy model, the output depends. Here it depends both on the present state. It depends both on the present state of the flip-flops, and also on the inputs. Okay, so you can understand this much better when I show you with the state diagram. Okay, so let us come to the state diagram. I shall take a small example of a state diagram which indicates the Moore and the Mealy model. Okay, so let me draw a small state diagram which will help you all to understand the concept of what is present state, what is next state, and how its present state and the next state is dependent on each other. Okay, so let me consider, let us write the topic as state diagram. Okay, So here is the state A, this is my B, here it is, let me take this as D and let me take this as C, and here I have something like 0 by 0, here I have something like 1 by 1, here I have something like 0 by 0, and here I have something by 1 by 1, okay, and this is connected like this, okay, and here it is connected like 1 by 0, okay, and here I have 0 by 0, here I have 1 by 0, okay. Now this is the representation. Now this is the state diagram, okay. You have the state variables A, B, C, D. You have 4 states because you have A, B, C and D. Now how do you know whether it's a Millet or the Moore model, okay? Now you have 4 states and each states have something, you have the digits, you have the bits represented in the form of a numerator and the denominator. Something represented in this fashion where you have a numerator as well as the denominator. So the numerator indicates the input, okay, and the denominator indicates the output, okay. So each state has its respective input and the output is called as the Millet model, okay. This is called as the Millet model, okay. So this is your input and this is your output, okay. Now see here how from this state diagram, like how will I derive the state table, okay. So state table, just listen carefully. I'll have to indicate the states. How many states do I have? I have 4 states. A, B, C, D is my 4th state, right? So these 4 states, I'll write it as present state. We already studied what is the present state, right? So these are my present state, A, B, C, D, okay. Now the next state, okay, I'll have to indicate my next state depending upon my inputs x is equal to 0 and x is equal to 1, okay. I shall write this over here, okay, 0 by 0, okay. This is what is my next state and what is its corresponding output when again x is equal to 0 and x is equal to 1, clear? Now just have a look. So come to the state A, okay. When input, see all these are my inputs. My numerator is an input, my denominator is an output, okay. This is my output and this is my input, okay. When I say the state A, when the input is 0, see state A, when my input is 0, it is coming to the same state. So I shall write it as A, correct? At that corresponding moment, what is its output? It is 0. So I shall mention it here as 0. Now consider state A when the input is 1. You can see the numerator is 1 over here and it's protruding from A. So this is going to be my input. So my state A when the input is 1, it is going to C. So I shall write this as C. Okay. So what is its corresponding output? 0. Okay. So I have completed with state A. Now come to state B. So state B, when the input is 0, where is it going? It is going to the same state. So I shall write it as B. Okay. So when the input is 1, you can see when the input is 1, it is going to the state A, right? Here is your 1. So it's going to a state A. I shall write here as A. So what is its corresponding output at that time? It is 0 over here. Okay. Now when it is in the same state, its output is 0 over here. And when it is having the input as 1, the output is 0. Okay. So we have done it with state B. Now what about state C? So when the input is 0, it is going to the state D, right? And the corresponding output is 0. When the input is 1, you can see it is going to the same state. So I shall write it here as C and the output as 1. So I have completed with the state C, right? And state D you can see when the input is 0, it's going to state B and the corresponding time its output is 0. And when the input is 1, it is going to the same state D. At this corresponding time, its output is 0. Okay. So this completes my state table. Okay. So something which is represented in this fashion where you have the inputs and the output and determining the state table in this way is called as the Millet model. Okay. Now let's see the Moore model. Okay. There is a simple difference between the Moore model. I'll just show you that. Okay. So in case of the Moore model, let us consider an example. So let this be C by 1 and let this be D by 0 and let this be B by 0. Okay. So let this be as 1 over here and let this be 0. Let this be 0. Okay. And let this be 1. And here let it be 1. And here let this be as 1. Okay. Here it is 0. Okay. And here it is 0. The major difference between a Moore and a Millet circuit is, here you can see that the input, okay, the input is the one which is protruding from any of the states. Okay, so all these are considered to be the input. Okay, whereas the output in case of the Moore circuit is something which is represented within the state. Okay, so these are the output of the Moore circuit. So C by 1, so this will be your output. Here 0 remains the output. Okay, and here 0 remains the output. Okay, so these are all the outputs, whereas the arrows with the digit or the bit 0 or either 1, all these are considered to be as your inputs. So this is the major difference between your Moore and the Millet circuit. Okay, now how do I write the state table? So state table is quite simple. So again I'll write the present state here, the next state here and the output. The major difference here you have to notice, you can write the states here. There are 4 states. I write the 4 states over here. And what about the next state? Okay, when x is equal to 0, what is my state? When x is equal to 1, what is my state? Okay, in case of the Moore circuit, unlike your Millet circuit, you will have only one output, because you can see that the state itself has the output which is represented. Okay, now coming to the state A. Okay, when your input x is 0, where does it goes? It goes to the same state, right? When the input is 1, where it is going? It is going to the state C. In both the cases, you have only one output which has been represented over here. Clear? Now come to state B. When state B, when the input is 0, it is going to state B itself, and when the input is 1, it is going to state A and its corresponding output is 0. Come to state C. When you have the input 0, it is going to state D. When it is 1, it is going to state C. Its corresponding output is 1. Coming back to D, when you have the input 0, it is going to B. When you have the input 1, it is going to the same state and its output for both the cases is 0. Okay, so this is the state diagram for the Millet circuit. And the major difference, as I told you all, here you have only one output based on any inputs each state can have. Okay, hope you have understood the concept of state, present state, the next state, the difference between Moore and Millet, the difference between combinational and sequential circuit, where these are all the basics for us to get into the design problems. Hopefully you have understood all the concepts. Thank you.